Welcome back to Success Arena Academy. In today's video, I'm going to be showing you how to derive equation of a progressive wave and also how to solve problem using this same equation of a progressive wave. If you are new to my channel, please don't forget to click on the subscribe button down below in the screen to subscribe to my channel and also like my video. Thank you. And also don't forget to comment on the video. I'll be waiting right here for your comments. Now let's continue. Now you see, in my previous video, we take a look at progressive wave and stationary wave. The difference between these two types of wave. As you have to know that a progressive wave is a moving wave. And when I was explaining wave to you, I made mention of something that's in wave. When wave is just a form of energy that is traveling through a medium. When it travels through a medium, it tends to create a vibration to the particles of the medium. Simply means each of these particles of the medium tend to vibrate from their mean position. Now, let's take a look at the displacement of each of these particles. Now, I should have to understand that if a wave can travel either from left to right, or the wave is traveling from right back to left. Altogether, now we can have different kind of displacements. Now, if assuming I have a particle that is located at this point, there are different particles located at different points on the wave profile. Altogether, let's say at this point here, I have a particle P that is located at a distance of x from the origin. Now, if the wave is trying to move from the left-hand side to this direction, then the particle at the origin here tends to be displaced first from its initial position. Now, if this particle at the origin is being displaced from its initial position, it tends to have this equation of a sine wave, which is y, the displacement of the particle, equals to a sine wt. Now, where this w simply represents the frequency, the angular frequency of the wave particle. Now, this is the angular frequency, which is expressed as W equals 2 pi times the frequency. Altogether, y this t is the time taken for the wave to travel and for the vibration, the particle of the medium to be displaced away from its initial position. Now, one thing I want you to understand again about a progressive wave is that for every progressive wave, each particles are vibrating with equal amplitude and frequency. Each of the particles have the same amplitude and the same frequency, but there is something that is different. What is it? You see, neighboring particles tend to have different phase. That means they are moving in different phase. For example, now, the particle that is here, the phase of the particle here is different from the phase of the particle here. The phase of the particle here is different from the phase of the particle here. Altogether, now the same thing, if I now locate a particle which is found at point P, a distance from x, then this particle, if particle O is displacing at a sine wt, then the particle at point P here does not displace at the same rate of a sine wt. Why? Because it has a difference in phase angle. Now we can find the phase difference between the particle at point P and the particle at the origin. Now, assuming we have the distance from the origin to this point here, let's say this point A, distance from the origin to this point here is taken as my wavelength. If this is the wavelength of the wave altogether, now don't forget that this wavelength represents, it covers one complete cycle altogether. Now, the phase of any particle that is located at point A here is equal to 2 pi, which is one complete cycle. Now, I can relate the phase of the particle that is located here with the phase of the particle at point P. Since the particle at point P is going to be lagging behind the particle at point O. Why is it lagging behind? Let me give a short note on that. Take a look at this. See, the particle is traveling from left to right. The wave is going to get to particle O before it got to particle P. It simply shows that particle O will be leading, while the particle P will be what? Lagging behind. What do I mean by leading and lagging? Simply means particle O will complete its own oscillation before particle P will start its own oscillation altogether. Now from here, if I have phase of particle at point P here, I can easily get the phase. Now, since the distance of particle at point P here to the origin is x, and the distance of particle at point A here to the origin is 1 wavelength, since the particle at point A here is having 2 pi radian as its own phase altogether, now I can easily relate this that x all over wavelength equals to the phase angle of the particle at point P all over the phase angle of the particle at point A, which is equals to 2 pi. Now I can easily get my phase angle. My phase angle here will be equals to 2 pi x all over wavelength, which is multiply this to this divided by this, I'll have this. Now this is the phase difference of the particle, where this s is representing the separating distance between the two particles of the medium. Altogether, between this particle at this origin here and particle here, this s represents their separating distance. Now, any particles along this wave profile will also have this same phase difference altogether. Now, let's continue with this that we have here. We can easily generate our equation of wave using this same thing that we have here. How do we do that? Don't forget I said something earlier on that this particle that is here at point P here is lagging behind particle at point O with a phase difference of phi altogether. So if it is lagging behind particle at point O with a phase difference of phi, then I can easily write the equation, the displacement of the particle here, with an equation as y equals a sine Wt minus phi, which is the phase angle, a sine Wt minus the phase angle phi. Now, if I substitute the value of this phase angle that is here into this equation, I can easily have y to be equals to a sine of Wt minus 2 pi x all over wavelength. Now, from here, we can easily get something nice. What can we get that is nice in this place here? The general equation of the wave can be gotten from here. And how do we get this? Now, normally we believe something that the wave number of wave is given as 2 pi over lambda. That is my wave number. This lambda is your wavelength. Now I can easily substitute this wave number to represent what is found in this place here, and I'll be having y to be equals to a sine into brackets Wt minus kx. It simply shows that the particle at point P is displacing as a displacement of a sine Wt minus kx. Altogether, we can further write this equation into different formats, but note something that this is the general equation for progressive wave. Now, I can further this equation by saying y equals a sine into Wt minus 2 pi x all over wavelength. Now, how do we go about this? Since my W represents the angular frequency, and my angular frequency is given as this 2 pi f, I can easily say y equals a sine W is my 2 pi frequency times time minus 2 pi s over wavelength. Now from here, we can quickly get something out. What can I get out from this? I can write this in terms of speed. We write this equation in terms of speed of the wave particle, the speed of the wave that is moving. Then from here, my y can be, let's take this. Since my speed of wave, let's use v. V equals to frequency of the wave times the wavelength of that wave itself. Then I'll be having my y to be equals to I can replace this frequency here as frequency to be equals to speed of the wave over wavelength. This is my frequency. Now I can substitute this back into this equation, and I'll be having y equals a sine brackets 2 pi. Instead of f, I'll be putting v all over wavelengths times t, then minus 2 pi s over wavelengths into brackets. Now there is 2 pi here, there is 2 pi here, there is wavelength, there is wavelength. Then you can easily remove something out here by saying y equals a sine 2 pi. 2 pi all over wavelength. That will be left with something of this kind that I'll be having Vt minus s. Vt minus s This is another form of the equation, vt minus x. Now we can also generate other forms of the equation. Now, another form of the equation can be written in this format. From this equation that is here, this is one form. Now, this is the general equation. It can be written for you in this format. Sorry, I use just a mark. Altogether. Now let's take a look at another form of the equation. The equation can also form in this way. Since I have here as y equals a sine wt minus 2 pi x over wavelength, this thing can simply be written as y equals a sine 2 pi, a sine, here, I have my 2 pi f times time minus 2 pi s all over wavelength altogether. Now, from frequency, we know that the frequency of a wave is always reciprocal of the period of the wave. I can write this equation in terms of period of the wave, whereby I'll be having y equals a sine. Now, I think 2 pi is common here. We can easily remove the 2 pi out. I'll be left with f times time minus s over wavelength, whereby I'll be having a sine, if here is 2 pi, okay, 2 pi brackets, instead of frequency I can easily put 1 over period, that is representing 1 over period, don't forget times time, minus s over wavelength. Now, I'll be having a sine 2 pi into bracket t over t minus s over lambda. This is another form of the progressive wave equation. Now, it can be expressed to you in any of these forms that is here, either in this case here or this one. And we have multiple forms of the equation, but note that this is the general form of the equation. Now let me now try to explain something better. Sometimes the equation might be written, this general form of the equation might be written in another way around. I said earlier when I was trying to prove it that if the wave is traveling from left to right, the particle gets to the point O, which is the origin, before it got to point P. That's why point P here is lagging behind, while the particles at point O is leading. Now, sometimes the wave might be moving from right back to left. Might be moving from right to left. Now, if the wave is moving from right to left, don't forget that that's going to give us a negative wave equation. Now, this one is a positive. When it is moving from left to right, it gives rise to a positive wave equation. If you take a look at your Cartesian coordinates, I have from something along this direction should give rise to positive. Backward like this will give rise to what? Negative. So you can have a positive wave equation and you can have a negative wave equation. Now, if it is going from right back to left position, it simply shows that the particle that is found at point P here, the disturbance will go to the particle at point P before it got to the particle at point O. Simply means point P will be leading, as in the particle at point P will be leading, while the particle at point O will be lagging behind. Now, don't forget that this particle lead or lag by 2 pi h over wavelength. Altogether, that's the phase difference that is found between the particle here and the particle here. Altogether, so if the wave is going like this, point P, the particle at point P will be leading, while the particle that is found at point O here will be lagging. We can rewrite this same equation for that. I think from here, let me try to remove something here. Now, if it is leading and lagging, then I can easily write it like this because I'm going to get here before here. The equation can be exchanged. The general form of the equation can be exchanged as y equals, some of you might be saying that some of the equation we have positive. Then that equation, this general form of the equation can be written as a sine wt plus kx. Altogether, what I'm trying to show you here is that what? The displacement of the particle at point P can be written as what? Wt plus ks if the wave particle is going from right to left. Altogether, why the displacement of the particle at the origin, in case you are seeing something of this kind, the displacement of the particle at the origin, don't forget that the particle at the origin is lagging behind. So if it is lagging behind, the displacement of the particle, I can easily write this as y equals a sine k minus WT. Altogether, this one is showing a negative wave equation, which is A sine KS minus WT. This is a negative wave equation, while this one is a positive wave equation. Let's take an example on how to use the equation of a progressive wave, of a plane progressive wave. Now, you're given a question on the board. So in this place here, I'm going to be showing you how the equation can be applicable. Now we have a traveling wave in a string is given by the equation y equals to 0.03 sine 2.2x minus 3.5. Altogether, now how do we go about this? The first thing I need to do here is I have the wave y equals, let's take its solution. I have wave y equals 0.03 sine 2.2x minus 3.5t. That is the wave that is here. Now, first of all, we say where y and x are in meters and t is in seconds, find the amplitude of the wave. Don't forget I said something later on that was a progressive wave always have a constant amplitude. It simply means each of the particles of the wave are moving with equal amplitude, and then they're also moving with the same frequency. The only thing that differs is that for a progressive wave, each of the particles they differ with a phase difference. Altogether, now from here I can easily fish out my equation. You know, if you want to solve using this equation, this is the equation given to you. You are going to write the equation of the wave that is related to this equation given to us. And the equation is, I have y equals to a, I'm having some things marker here. Y equals to a sine, this one should be Ks minus Wt. Now, this is the major equation, the general equation of the progressive wave. Now, the next thing is that you are going to relate this equation to what you are given on the board. Now, if I relate it, this is my sine, this is my sine, Now, I have 0.03 to represent my A. It simply means my question 1 has been done. The amplitude of the wave, which is the first question, amplitude A should be equals to 0.03. I think everything is in meter. 0.03 meter. That is my amplitude of the wave. Just relate it from here. This is my amplitude related to this. Now, if I relate it generally, I can have this is S, relating X together. If I'm equating S and S, my K should be equals to 2.2. That is my K altogether. While my angular frequency, W, should be equals to 3.5. 3.5, that is my angular frequency, W, altogether. Now, we are now asked to calculate for the wavelength. How do I get the wavelength? Your wavelength can be gotten from the wave number, which is K. My K is my wave number. So from K, I can get my wavelength. How do we get it? From here, my wave number K equals to 2 pi all over wavelength, whereby my wavelength will be equals to 2 pi over K. 2 pi over K, where I'll be having 2 multiplied by 3.142. That is the value of pi. You have to use the exact value of pi, which is 3.142. And then all over my K, which is 2.2. Now, if I can get my calculator from here, to get the exact value of my wavelength, I should be having 2.86 for my calculator. 2.86 meter. That is, if you calculate this together, I'll be having 2.86 meter. That is my wavelength. Now, the next one, you have to calculate for the frequency of the wave. Don't forget that the frequency of the wave can be gotten from the angular frequency, which is given as 3.5. Don't forget that this thing should be in radian per second. That is the unit, radian per second. Why this one is in per meter? Per meter, that is the unit of wave number, per meter. Now, I want to find the frequency. This is my question 2, the wavelength. Now, my question 3, we have to find the frequency. Since my angular frequency W omega equals 2 pi f. That is my angular frequency, 2 pi f. So from here, I can easily say my frequency will equal to W over 2 pi. And then, what is my angular frequency? I have 3.5 as my angular frequency over 2 times 3.142, which will be given frequency at this moment will now be given as this. Your angular frequency W divided by 2 pi, which is going to give rise to 0.56 Hertz. That is my frequency altogether. Now, the next thing in the list is that we have to find the period of oscillation. Now, this period, don't forget my period is always related to 1 over frequency. Now, if your period is related to 1 over frequency, then my period can be equal to 1 over 0.56, which this can give rise to 1.80 seconds. That is my period of oscillation. Now, the next one is now to calculate for the speed of the wave. Now, you can easily get the speed of the wave from this. Look at something here. I have a relationship that V, the speed of the wave, is always equal to the frequency times the wavelength of the wave. Now, we can also take it as this V equals to, since my frequency is 1 over period times wavelength, I can also have wavelength over period is also the speed of the wave. So anyone you like to use, you can use this to get the speed by using your frequency, your value of your frequency times your wavelength, or you use your value of your wavelength divided by your period. Any of them is going to give you the same answer. So my V should be equals to something of this kind. I should be having. Now, my V will be equals to my wavelength given to me initially that I got, is 2.86 divided by my period that I got is 1.80. That should give rise to 1.5 something. If I'm not mistaken, that should be 1.59 meter per seconds. That is my wave speed. Dividing this, I should be having 1.59 meter per seconds. That is the wave speed of the equation. I'm sure that this is well explanatory to you, that you really understand what is there. Now, all questions can be solved the same way like this. If you are given another equation that is different, sometimes you might be given a positive equation whereby I'll be having t first before x. That means here will be t, while here will be x. The only thing you just need to do is to rewrite this equation. If I know what is here is t and what is here is s, the only thing I will just do is that I will just rewrite this equation by changing this to be equals to wt minus kx altogether. So you can rewrite it so that you can have relate the equation together with this. But here it is different. I have x, I have t, and here we are using kx minus wt. Thank you for watching this interesting video. Please stay connected with me, and don't forget to click on the subscribe button to subscribe to my channel, and also follow me on my Instagram page. Follow me on my Instagram page and my Facebook page to see more videos of this kind. Don't forget, like my video and drop a comment for me in the comment box section below. Thank you. Meet you in the next video. Thank you.